Well, welcome everyone. Hope you've been having a great day at Decouple Days. And today I'm here to talk to you about declarative management with XState. Real quick intro about myself. My name's Daniel LeMay. I'm a senior developer at Phase 2 Technology. We're a digital consulting agency where we focus on creating digital experiences that advance the human experience. I'm primarily focused in the front-end app building space, as well as tooling. Recently, I've been building several progressively decoupled apps within existing Drupal sites. You can follow me on Twitter at DSLMA. I'll be tweeting out a link to the slides and as well as some code examples after the talk. So real quick agenda. Today, we're going to be talking about some state management pitfalls, what are state machines, and how we can build and use state machines. So diving right in, let's talk about some common state machine or state management pitfalls. So generally when we're dealing with application state, it starts off pretty simple, but inevitably our requirements change. We bolt on additional functionality, and that additional functionality often comes with additional state complexity. Now, we may or we may not handle that state complexity, and it may or may not be obvious to us that it even exists. When we don't handle things properly, users often take different logical flow paths, and they end up reaching undesired application states that we find out in error logs, and we're like, how did the user even get to that state? So those are some of the pitfalls that we're going to try and resolve with state machines. And as a quick preface, all of the code examples that I'm going to be going through are going to be using React. But the problems and the solutions are not constrained to React development. You can use them in any programming language, any JavaScript framework, or even vanilla.js. So let's go through a sample fetch machine, or a sample fetch component that is not using a state machine. So here we are handling several pieces of state, whether or not we're loading, do we have results, do we have an error message? We're using just the plain use state implementation. If we were using use reducer hook, like this would be very similar. We'd just have one state object instead of individual state values. And then we're conditionally loading parts of our UI based off of the truthiness of those values. So if loading is true, we're going to display a loading data div. If we have an error, or if error is not falsy, we're going to display that error. And then when we click this button, we're going to fire off this fetch questions, where we've got kind of this very imperative programming style where we have to set as loading to true so we can display our loader. We'll try our fetch. If it's successful, we'll save the results. We'll set as loading back to false. And if we get an error, we'll save the error. But there's several problems even with this really simple component. For example, what happens when I get an error on the first fetch, but I refetch and then I have a successful fetch? Well, I forgot to clear the error message, so I'm going to get data and an error message, which that's not something that we would want the user to see. Also, like if I spam press the button, I'm not really currently handling in the application if we're currently fetching as a guard to eject out of the fetch question. So we could cause like some janky UI. Now, obviously I could implement that, but it's just additional things that I need to be thinking about. And kind of the core issue at hand is that we're using these values as flags to determine the rendered output without handling all of the possible cases. This is generally a problem with bottom-up or implementation first approaches. And generally speaking, we don't handle all of the additional complexity. And that's due to a concept called combinatorial explosion. So that's a big fancy like mathematical term, but we won't get too far into like mathematics today. In short, combinatorial explosion is measuring the complexity of a problem, and it's created by the groupings of potential combinations to form a set. So in combinatorial explosion, that complexity grows rapidly and often at an exponential rate. So in our previous example, we had 3 pieces of state that we were matching against, and we were kind of matching the combinations of those to create a set state that we want to be in. So we may have only wanted to have 3 states in our application, but we actually had 8. And we probably didn't think about all of those, and we probably haven't handled all of those. So this is often a contributing factor to reaching undesirable states. And so the question comes is like, how do we solve this? And that's where state machines can come in. So at a high level view, state machines are a decades-old pattern where we specify the states that a machine can be in and transition between the states via events. They're both deterministic and they're pure functions. You'll hear me referencing XState a lot. XState is a JavaScript library that implements state machines specifically. And it also kind of expands upon that to something called state charts, but we won't go into that specifically today. So we're going to cover three kind of core concepts that most state machines have. There's additional functionality depending on your use case, but most state machines have these three things. So the first thing is we're going to need to enumerate all of our potential states. So we need to know what they are. We're going to list them in advance within our machine so that we can't transition to an unknown state. Then we have events, and events are how we transition between states. This is kind of a similar pattern to Redux or the use-reducer hook, if you've used either of those before, where we're dispatching events and firing off different logic based off of the action type that we've sent. But with state machines, there's an additional layer of logic available because each state can respond to or ignore events differently. So maybe not all events will be listed on all states, and generally they aren't. And lastly, we can store additional data in context. And so context is how we can store our additional configuration for the machine of runtime data. So where we store our results, maybe some user information, the current page in a pager system. Those things that aren't states in and of themselves, you can think of them as like extended state. So here's a quick visualization, and this is actually from the XState visualizer tool. And what you can get when you start building state machines. So here we've got the little blue arrow that's pointing to where our state machine is going to initialize in. The more rectangular boxes for idle, loading, success, and failure, those are our states. The more pill-shaped bubbles are our events that we can dispatch on a given state. And then underneath success and failure, where we see do set results or do set error, those are actions. And actions are how we can kind of mutate or create new contexts. So we're going to actually go ahead and create this machine with XState right now. So right now I've got the XState visualizer up, and you go to xstate.js.org. You can click on visualizer, and you can actually just start building a machine right away. This has all of the global or all of the named exports from XState as globals, so you can just start using them. You don't have to worry about importing anything. And here we have a really simple machine. It's actually not really super helpful, but what we've done is we've started with this machine call. This is how we create a machine, and its first argument is an object. And it's expecting a states key, which is an object of all the possible states that we can be in. So here we've declared that we have a loading or an idle state, a loading state, success, and a failure state. And then we also need to specify what state our machine should initialize in. So we'll say we're going to initialize in idle. And so we can see over here, we do enter the idle state, and we have our 4 states, but we don't have any means to get from state to state. So let's go over here and we can see how we can do that. So when we open up each state object, we can pass in a on key, which is also an object. And here's where we can declare all of the events that that particular state responds to. So here we're saying when we're in the idle state and we receive a fetch event, transition to the loading state. Similarly, if we're in the loading state and we receive a success or a failure event, we'll transition to the success and failure states respectively. And on success and failure, they both also respond to a fetch event, and we'll transition back to the loading state. And so we can see here now we've got these branches. So I can see that I'm in the idle state currently, and if I click on fetch, I've now transitioned to the loading state. If I click failure, I'm in the failure state, and I can go back to fetch. Now, this is great. We're making progress, but we still aren't really storing data, and we may want to store data, for example, on our results. So to do that, we can use context. And Here, at the same level as states and initial, we can specify our context object, and we can initialize those if we want. So we're going to specify results as an empty array and error message as an empty string. Now, we're not going to have the same problem that we had previously, where we were switching on the values of these. We're actually going to be switching on the values of the state that we're in. So we're not going to have that same error message problem that we had previously. We'll get to that when we actually do the implementation. And then in order to update the context, we need to fire off actions. So if we go down to our loading state, previously we had this success and it was just a string of success. And now we've kind of changed it and we've made this an object with a target key, which is the success. If we just had that where it was success object with a key of target, that's actually means the exact same thing as our previous implementation. It's just syntactic sugar that XState provides for a terser syntax. But since we do need to fire off an action, we can't use just the string version. We need to use the object version. And so we're going to specify an actions key. These are going to be actions that will be fired when this event occurs. And we're going to create an action. So we'll have set results for success and set error for failure. Now, if we scroll down below, previously we had only used a single argument for creating our machine. But machine can actually accept multiple arguments. It can accept two. The second argument is going to be this configuration object. So it's, again, an object, and we can specify actions. And here's where we define all of the logic for our actions. So first, we'll go into set results. This assign function right here is a function that is from XState, and it's it's the interface for us to update our existing context. We call that with an object and the keys that we want to override. And this again is a pure function. So we want to change the results. And in order to do that, we have a function that will return the new data that should be assigned to that key in context. And that function always has the same signature. We get the existing context as the first argument and the event as the second argument. Again, if you've used Redux or the use reducer hook, this probably looks very similar of we get the previous state and we get the action that was fired. So for set results, we're going to just return the event.data. And for set error, it's going to be very similar, except we're only affecting the error message, and we're going to send that to event.message. So now if we go and we get into our loading state, we can actually see in here, we'll actually reset that. We can see we're in idle right here. And if we hit fetch, we go to loading. This is the state object that would be returned when you're using the machine. And currently our context is empty. But then if we switch over to events, we can actually call this success type. And we'll just add in here, we were expecting a data key. And we'll say 1, 2, 3, 4. So we can send that, and it's just a JSON object. We'll send it. You can see we fired that event. We can see we're in the success state over here. And now if we go back to the state, we can see our results are properly listed. So that's the basics of how to create a state machine with XState. There's a lot more power to it and a lot more functionality, but that's like the bare bones to get going, and you can do a lot with just what we've covered so far. So how do we actually use that state machine? So XState also provides a use machine hook to instantiate the machine. They also provide kind of additional libraries for, I believe, Vue, and I don't remember if they have one for Angular. Again, you can instantiate a machine just in vanilla JavaScript. They provide functions to do that out of the base XState package. All the use machine hook does is it kind of removes some of that boilerplate from you having to handle that and puts it into kind of a nice little package. So this use machine hook returns a tuple where we get our current state and we get a send function, which is how we send events into the machine. And what state allows us to do is we can access our context just with state.context. We can access any of the fields in there. We can also see what our current state value is using state.value. But one of the real superpowers of using XState is it gives you the state.matches, which is a function where we can pass in a string representation of the state, and it will return true if we're in that state, and it will return false if we're not. This becomes even more handy when you use like some further features of XState to like have nested states or parallel states. Now send is again how we get send our events into the machine. So here are fetch questions. We start off by saying we're going to send a fetch event. We again try and do our fetch. If we're successful, we'll send with the data. If we fail, we will send a failure event. But we have kind of some key differences in this implementation and the previous one. First off is our button, if it gets smash clicked a whole bunch of times and our fetch is still on flight, we're not going to have multiple API requests because we explicitly didn't allow a fetch event when we're in the loading state. So that's already taken care of for us. We don't need to worry about implementing that logic ourselves. And now we also truly only have our 3 usable states. We have our idle state, which we don't really use too much, just kind of where we're starting the machine because we don't want to start any loading state. So this really represents what we expect our app to, how we expect our app to behave, instead of having 8 potential states that are really hard to reason about. So there's several state machine benefits. The first is they are deterministic, so you can really focus on making your impossible states impossible. I really regularly start reaching for them if I know a piece of the application is going to be moving through a series of states, or if I start seeing multiple flags where I'm creating a combination of them to form a state. That really has become a code smell for me personally, where I think that state machines are a better fit. Additionally, the business logic is not tied to a specific UI implementation, or even if there's no UI at all in the case of Node. It can be lifted and shared across those implementations for even further code reuse. One of the things that I think is amazing and excellent about React hooks specifically is like there's all these libraries coming out with shared React hooks and wrapping all of this logic for increased reuse. But they're really constrained to React, and some of those problems may not just be React problems. With state machines, it's possible to share those machines across implementations, across frameworks, and configure them to respond differently by supplying a different context. In practice, I've had machines as small as 50 lines of code and as high as 200. Another really big benefit that I've found is business requirements often change. New features are added, or someone comes in at the last minute and it's like, oh, I forgot we needed this. And then we're expected to adapt and kind of work within those confines. With state machines, that becomes a lot more straightforward because oftentimes we need to like tweak the config, maybe fire off an action in a different state, allow another state to respond to an event. It becomes a lot more straightforward in my experience. And again, this is just a very high level of all of the things that XState can do. There are so many more things that we didn't cover, including orthogonal or parallel states, hierarchical and nested states. There are services to interact with promises, to have an even better interface working like with fetch calls, or if you're using observables. There's also things called history states, which let you kind of maintain knowledge of your application, your state machine's state when you navigate around in it. If you're curious to hear more, I really recommend the XState docs. They're a great place to learn. They give a lot of examples of how to use the different pieces, and a great launching off point. And with that, thank you so much. since we actually finished early, I have some examples of some more complex states. Since I didn't see too many questions, we'll show these real quick. Here's another machine that I wrote. I'm not going to walk through the code, but just going to kind of walk through the UI. This is a machine that I created for this talk of how has a particular technology received enough hype to be worth me exploring. So here we have, we'll hear the technology mentioned. We're actually paying attention to see if it's been mentioned more than 2 or more times. So this is using something conditional. So previously it wouldn't let me go to the investigating state because I didn't satisfy this condition. But now if I go to it, I can see that I'm in the investigating state, and I can invest, or I can go into not interested. Maybe in not interested, there's this really insistent colleague that's probably me that keeps saying, you should really try this technology. And if we get to that, we go back to the investigating state. And both of these times we can form opinions. And then lastly, I'll just show this one real quick, and then we can dive into some questions. Is like, this is an example of a pager that is like very complex and like has a lot of nested conditionals.